Most neuroscientists focus their studies on the structure and operation of the brain. And for 17 years, I did too. But more recently, I've become interested in the structure and operation of the mind. We know a lot about the brain. It's 100 billion biological cells called neurons that are networked together and sending messages to each other in the form of electrical signals. But we don't know a lot about the mind. We don't know what thought really is. However, we can break down the problem of consciousness into two different parts. The first is this cohesive stream of perceptual awareness that we all have, the flood of sights and sounds and smells that characterize the mental experience. The second aspect of consciousness is a feeling of a self who is having that experience. The self is the one who collects data from the world through the senses, develops beliefs about the world, and interacts with the world through behavior. So we're not just aware, we're also aware of being aware. And in order to understand consciousness, we really need to understand both of those aspects of it. To talk about consciousness, we really need to begin by talking about reality. We live in 3 dimensions of space and 1 dimension of time. We collect data from the world through our senses: seeing, hearing, smelling, tasting, pain, pressure, temperature, the feeling of that racing heartbeat. These data are converted into electrical signals that our brains can understand. Photons of light hitting our eyes are converted into electrical signals that our brains can understand. Sound waves hitting our ears are converted into electrical signals that our brains can understand. These data travel to our brains and are processed there by networks of neurons. Visual data is processed in the visual cortex. Auditory data is processed in the auditory cortex. But there's no one spot in the brain where all of these data come together to form that cohesive mental experience. And what's more, even if there was a single region in the brain where all of these data come together, that neural activity would not be the same as mental experience. Consciousness is not the same as neural activity, even though neural activity is required for consciousness to happen. We know this is true because when our neural activity changes, our mental states will change. And if we damage our brains, our perceptions and our thought patterns will change as well. So neural activity is tied to consciousness. But consciousness is something different from neural activity. The truth is, perception is a reconstruction of reality, made possible by the sensory data that we have collected. The amazing variety of colors that we see are determined by the type of photoreceptors in our eyes. The sounds that we hear are determined by the shape of the cochlea in our ears. The senses we have both facilitate and limit how we observe reality, allowing us to reconstruct a first-person view of the world that is continuously updated in real time. That mental experience is very much tied to neural activity, but it's also something categorically different from neural activity. It almost seems as if the mind exists in some other dimension, not in our observable universe. And I would like to argue that that is exactly the case. The mind exists in a separate spatial dimension from the brain. While information about the world is encoded in the brain in the form of neural activity, the rich qualitative information content of the mind exists as a holographic projection in higher dimensional space. Now, there's some complicated concepts here, so let's take it step by step. Thank you for bearing with me. begin, let's explore what spatial dimensions are and how they're formed as functions of time. So let's imagine a zero-dimensional point. The point may exist in our three-dimensional world, but the point itself has 0 dimensions. Now let's imagine that this zero-dimensional point moves through time. In doing so, it creates a one-dimensional line. The sum total, or integration, of all positions taken by this zero-dimensional point is a one-dimensional line. By drawing the line, we have just created a spatial dimension. Now let's imagine that this one-dimensional line moves through time. In doing so, it creates a two-dimensional area. The sum total, or integration, of all positions taken by a one-dimensional line is a two-dimensional area. Now let's imagine that this two-dimensional area moves through time. In doing so, it creates a three-dimensional shape. The sum total, or integration, of all positions taken by a two-dimensional area is a three-dimensional shape. Now, this pattern is actually a geometrical law, and it goes like this. Any n-dimensional shape that is changing over time becomes an n+1 dimensional shape. I'll say that again. Any n-dimensional shape that is changing over time becomes an n+1 dimensional shape. That one-dimensional line becomes a two-dimensional area. That two-dimensional area moving through time becomes a three-dimensional object. Any n-dimensional shape that is changing over time becomes an n+1 dimensional shape. Let's take this logic one step further. The brain is a three-dimensional structure. While it retains that structure, it is also changing over time as electrical activity flows through the structure. By geometrical necessity, a three-dimensional shape that is changing over time becomes a four-dimensional shape. The sum total of all the electrical activity, all the movement of charged particles over a given moment in this three-dimensional structure is the integration of information across that neural network structure, and that has to exist in another spatial dimension. That integrated information is the cohesive stream of perceptual awareness. It is that reconstruction of reality that's continuously updated in real time as the neural activity itself changes. And all of those moments, all of those snapshots in time are integrated together to form yet another spatial dimension. The sum total of information collected by a neural network over an entire lifetime is the self. The self is the integration of all your experiences, all of your neural network states, all the information that you've collected. It's constantly updated in real time with information that can be included or rejected or deemed redundant. So if the fourth spatial dimension is comprised of the flux of information over a given moment, then the fifth spatial dimension is the entirety of information collected by that neural network. So I propose to you that we are five-dimensional shapes. While our bodies and our brains exist in the three spatial dimensions of our observable universe, our minds exist in an information streaming dimension and an information accumulating dimension. The brain holds the information content, encoding it in neural activity, while the mind holds that rich, qualitative information content. Perception, then, is the sum total of information in the brain over a given moment. It's very much tied to the neural network that created it, and it is constantly updated in real time. The self, meanwhile, is the sum total of information collected over a lifetime, minus what we have forgotten or chosen to omit. And just as information can be encoded on a two-dimensional surface area and projected into a three-dimensional hologram, the information encoded on a three-dimensional neural network structure can be projected into a higher spatial dimension. If our minds truly are information content, obeying the laws of math and physics, then we can follow these laws to learn more about our minds and to find out whether this information content is indestructible or in what form or what dimension it might survive our bodies. Our brains follow incredible mathematical and physical laws to reconstruct a useful experience of reality, which allows us to collect data from the world and to act effectively within the world. Considering these laws in greater detail will help us to understand the structure and operation of our worlds and our very selves. Thank you.